Hello everyone, welcome to the lecture again. In the last class, we saw how can we find out the moment of inertia of a body. Today, we are going to discuss how to find out the moment of inertia of composite bodies. So, the moment of inertia of composite bodies. Let us say I have a body like this. So, a sphere, a cylinder and then a sphere, and I want to calculate what is the moment of inertia of this about, let us say, the y axis. So, y prime. The moment of inertia will be the moment of inertia of the first sphere plus the moment of inertia of this cylinder plus the moment of inertia of the second sphere. Let me write it down in the text. If a body is divided into composite parts, the moment of inertia of the body about a given axis equals to the sum of the moment of inertia of its part about that axis. Okay. Now, note that the moment of inertia of all subpart must be calculated with respect to the same axis. Okay. So, this is what I said, when you want to calculate the moment of inertia, let us say for this composite structure, then the moment of inertia will be equal to this plus that and we have to calculate the moment of inertia of all the subpart about the same axis, which is y prime here. Now, based on this concept, let us look at a few questions. So, this is the first problem statement. An assembly is composed of 3 homogeneous bodies the 10 kg cylinder, the 2 kg slender rod and the 4 kg sphere. For this assembly, calculate Ix, which is the mass moment of inertia about the x axis. Okay. So, here we have 3 bodies. Let us label them 1, 2 and 3. Okay. We have to calculate the moment of inertia about the x axis. So, let us first look at the moment of inertia of the first subpart, which is the sphere. Okay. The moment of inertia of the first part about the x axis will be, so our x axis is this. Okay, we have to calculate what is the moment of inertia about this axis. So, we can use the parallel axis theorem. It will be the moment of inertia of this 4 kg sphere about its central axis plus m into h square. Okay. So, it will be 2 by 5 m r square plus m into the distance between them. So, it is 0.27 square, and now we can put the values. So, it will be 2 by 5 into mass is 4 and the radius is 0.09 square plus 4 into 0.27 square. Okay. And this comes out to be 0.30456 kg meter square. Now, let us look at the moment of inertia of the second object, which is the rod, about the x axis. So, we know that the moment of inertia of a rod about this x axis is m L square divided by 12. Okay. Now, let us see what is L. So, the L is 0.27 minus the radius. So, this is 0.27 minus this radius will be that length. So, minus the radius is 0.09 plus 0.24 minus 0.06. Okay. And this is equal to 0.36. This is our L. So, let us put the value. M is 2 kg. So, it is 2 kg multiplied by L, which is 0.36 whole square divided by 12. So, this is 0.0216 kg m square. Now, the moment of inertia of the third subpart, which is the cylinder, about the x axis will be the moment of inertia about this axis plus m into this distance square. So, the moment of inertia about that axis will be m by 12 3 r square plus h square. This is something that we discussed previously, plus m into this distance square, which is 0.24 square. Okay. Now, let us put the values. So, it will be 10 divided by 12, 3 into 0.06 square plus h is 0.3. So, 0.3 square plus 10 into 0.24 square, and that comes out to be 0.66 kg meter square. Therefore, the moment of inertia of the whole assembly about the x axis will be I x 1 plus I x 2 plus I x 3, which is equal to 0.30456 plus 0.0216 plus 0.66, that is equal to 0.98616 kg meter square. Okay. Now, let us look at another problem. Question number 2. A steel forging consists of a 150 cross 50 cross 50 mm rectangular prism and 2 cylinders with diameter of 50 mm and length 75 mm as shown. Determine the moments of inertia of the forging with respect to the coordinate axis. The density of steel is 7850 kg per mm cube. Okay. This system consists of two cylinder and prism. We have to find out the moment of inertia about the x, y and the z axis. Let us first look at the mass of this prism. So, the mass of the prism will be the density multiplied by the volume. So, the volume is 0.05 into 0.05 into 0.15 because the length is 150 mm and multiplied by the density 7850 and that comes out to be 2.94 kg. Now, let us look at the mass of each cylinder. So, the mass of each cylinder is again the volume. So, the volume is pi into r square. So, 0.025 square multiplied by the height of the cylinder which is 0.075 and then multiply by the density. So, that comes out to be 1.16 kg. Now, let us first look at the moment of inertia of the prism. And because of the symmetry, the moment of inertia about the x and the z axis it will be the same. So, I x equal to I z and we know the formula, it is m by 12 b square plus c square where b is 150 mm and c is 50 mm. So, let us put the value. So, it is 2.94 divided by 12, 0.15 square plus 0.05 square and that is equal to 6.125 into 10 to the power minus 3 kg meter square. And the moment of inertia about the y similarly it will be 2.94 divided by 12 into 0.05 square plus 0.05 square. Okay. And this is equal to 1.225 into 10 to the power minus 3 kg meter square. Now, let us look at the moment of inertia of the cylinder. So, the moment of inertia of the cylinder about the x axis is half m a square plus m y square let us say. Okay. So, first I calculate what is the moment of inertia about this axis and then m into this distance square. So, it will be half into 1.16 into 0.05 square plus 1.16 which is the mass into the distance. So, 0.05 square and that comes out to be 3.263 into 10 to the power minus 3 kg meter square. Now, the moment of inertia of the cylinder about the y axis will be equal to the moment of inertia about this axis which passes through the center plus m into this distance square. Let us call it x bar. So, we have used the parallel axis theorem. So, the moment of inertia about the y axis will be the moment of inertia about the axis that I have marked by the red dot and that is equal to m by 12 3a square plus L square plus m x bar square. Now, let us put the value. So, it is equal to 1 by 12 into m is 1.16 into 3 into 0.025, that is the radius of this cylinder, plus 0.075 square, plus m is again 1.16 into the x bar. X bar is equal to this distance, which is equal to 50 divided by 2, 25 mm, plus that distance, and this distance is equal to 75 divided by 2, which is equal to 37.5 mm. Therefore, x bar will be 0.0625 square, and that is equal to 5.256 into 10 to the power minus 3 kg meter square. Now, let us look at the moment of inertia about the z axis. So, that is equal to m by 12 3a square plus l square plus m x bar square plus m y bar square. Okay. So, how do you do that? So, we calculate the moment of inertia about this axis, and then we use the parallel axis theorem. So, that is equal to, you can calculate 8.156 into 10 to the power minus 3 kg meter square. Now, for the entire body, the moment of inertia about the x axis will be the moment of inertia of the prism plus the moment of inertia of two cylinder. Okay. So, that is equal to 6.125 into 10 to the power 3 plus 2 into, because there are two cylinder, the moment of inertia of each cylinder. Okay. So, that is equal to 3.263 into 10 to the power minus 3. This is equal to 12.65 into 10 to the power minus 3 kg meter square. Similarly, the moment of inertia of the entire body about the y axis is 11.74 into 10 to the power minus 3 kg meter square, and the moment of inertia about the z axis will be 22.44 into 10 to the power minus 3 kg meter square. Now, let us look at another problem statement. Question number 3, a ring with mass m is cut from a thin uniform plate. Determine the mass moment of inertia of the ring with respect to A, the axis A prime, and B, the centroidal axis C prime, that is perpendicular to the plane of the ring. Okay. So, here the moment of inertia of this ring, let us say this is your A prime and this one is B prime, and then we have C prime. Okay. So, this radius is R2 and this is R1. Now, the moment of inertia of this assembly will be equal to the moment of inertia of the outer ring minus the moment of inertia of the inner ring. Okay. So, let us calculate. So, it is given that the mass of the ring is m, let us say the density or the mass per volume is rho. Okay. So, therefore, mass m will be equal to rho times the volume, and the volume is the thickness multiplied by the area. So, which is pi r 2 square minus pi r 1 square. Therefore, rho is equal to m over pi t r 2 square minus r 1 square. Let us call this equation number 1. Now, by symmetry you can see here that the moment of inertia about A A prime will be equal to the moment of inertia about B B prime. Okay. So, this is from the symmetry I A A prime will be equal to I B B prime, and I C C prime from the perpendicular axis will be equal to I A A prime plus I B B prime. So, therefore, that is equal to 2 I A A prime. Now, let us calculate the moment of inertia about A A prime. So, that is equal to the moment of inertia of the outer ring minus the moment of inertia of the inner ring, and the moment of inertia of the outer ring about A A prime will be equal to m r square divided by 4. So, it will be m prime r 2 square divided by 4, wherein m prime is the mass of the outer ring minus m double prime r 1 square divided by 4, wherein m double prime is the mass of the inner ring. So, let us put the value. M prime will be equal to the density into the volume. So, the density is rho, volume is thickness times the area, and the area is pi r 2 square into r 2 square divided by 4 minus the mass of the inner ring is equal to rho into T into the area pi r 1 square, and then we have to multiply it by r 1 square divided by 4. So, this is equal to pi rho T divided by 4 r 2 to the power 4 minus r 1 to the power 4. Now, we can put the value of the rho here from equation number 1. So, that is equal to pi T divided by 4 into rho. Rho is m over T pi r 2 square minus r 1 square into r 2 to the power 4 minus r 1 to the power 4, and here pi and t will get cancelled, and this is equal to m divided by 4 r 1 square plus r 2 square. Hence, the moment of inertia about C prime will be equal to 2 times I A A prime. So, that will be m by 2 r 1 square plus r 2 square. Okay. Now, let us look at one more problem on the same concept. The 290 kg machine part is made by drilling an off center 160 mm diameter hole through a homogeneous 400 mm cylinder of length 350 mm. determine the mass moment of inertia of the part about the z axis. Okay. So, again here the moment of inertia of this entire structure will be equal to the moment of inertia of the outer cylinder okay. So, we calculate the moment of inertia of this about z prime minus the moment of inertia of the cylinder that is removed. Okay. So, let us find out the moment of inertias. So, first of all the density rho will be equal to the mass divided by the volume. So, volume is pi r a square minus r b square into h, wherein I call this as A and this as B. Okay. So, we can put the values because everything is given, mass is also given and R A and R B and H are known. This comes out to be 7849 kg per meter cube. Okay. Now, the mass of A is equal to rho pi r a square into h. Now, rho is known and all other parameters are also known. So, this you can find out, it will be 345.2 kg. Similarly, the mass of B will be rho pi r b square h and that is equal to 55.2 kg. Now, the moment of inertia of cylinder A about the z axis, that will be equal to half m a r a square. Let us put the value. So, that is equal to half into mass is 345.2 into r a, the radius of cylinder A is 0.2. So, therefore, 0.2 square and that comes out to be 6.904 kg meter square. Now, the moment of inertia of cylinder B about the z axis. So, this we can find out using the parallel axis theorem, that is the moment of inertia about the central axis plus m into this distance square. So, it is equal to half m b r b square plus m b into, let us say this is d. So, that is equal to d square. Let us put the value half m b is 55.2 into r b is 80 mm. So, 0.08 square plus m is 55.2 into d, d is 110 mm. Okay. So, that is equal to 0.11 square, you can put the value and it comes out to be 0.845 kg meter square. Therefore, the moment of inertia about the z axis will be the moment of inertia of A about the z axis minus the moment of inertia of B about the z axis. So, that is equal to 6.904 minus 0.845, that is equal to 6.059 kg meter square. So, this is how we can calculate the moment of inertia of the composite bodies. With this, let me stop here. See you in the next class. Thank you.